Rishan, any doubt?
No, sir.
Okay. We have just started dimensionless and we have done how to solve dimension of different quantity. Let's suppose if you have to calculate sum of heat quantities and sum of electrical quantity, some important term, I'm giving you some examples. Find dimensions. First, Boltzmann constant. It is denoted by Kb, and the formula for this particular term is kinetic energy is equals to 3 by 2 times Kb into T. K is kinetic energy, Kb is Boltzmann constant, and T is temperature here. Temperature is measured in terms of Kelvin, so it will have dimension formula as capital K. Rearrange this particular equation and try to obtain this particular Kb. Okay. Try to solve. Yes, Rishan, tell me. Okay.
Sir, what is the meaning of Ke there, the full form?
K is kinetic energy. The first thing is to rearrange this particular term on the basis of which term we have to calculate to one side and rest the all term to other side. So just keep it to one side and move all the other term to other side. It will be like kinetic energy 2 divided by 3 divided by T is equals to Kb. Okay. Now 2 and 3 are numerical value. So they are unitless and dimensionless constant term. So just neglect them. This is your kinetic energy and having same dimension as compared to energy, work done, or heat or torque, as we have done in our last class. Similarly, T is temperature here and it has dimension formula as capital K. So put the dimension and rearrange them to find the dimension of Kb. Okay.
Yes, sir.
Rishan, is it clear now? Okay. Send your answer to MZ in chat box. Yes. Avinav, check your dimension for K. Iram, do you have any doubt while solving? No, it's correct. Good. Rishan, Nida, Iram, send your answer. Riba,
Sir, what's the dimensions for kinetic energy?
we have done in our last class. Work done, energy, heat, all are same term. So the energy means any form of energy, whether it will be potential energy, kinetic energy, heat energy, thermal energy, all would have same dimension as ml squared t minus 2. Okay. Riba, any doubt?
No, sir. I'm sending the answer.
Okay. Good, Abhinav. Good. Nida, you may write dimension in the chat box as m1, L2, T2, or minus 2 plus 2 instead of getting it exponential. Rehab, we are doing just, we are trying to calculate dimension of some term related to thermal or heat. The first one is Boltzmann constant, for which the formula is this to calculate this particular KB. Similarly, we have to calculate dimension of specific heat constant. So here Q is heat, that is energy, M is mass, S is specific heat constant, and delta T is temperature. So just rearrange them to find this particular value of S.
Sir,
Yes,
said like in the paper, if they give us such terms, so will they give the formula with it?
no, you
I have
have
to
to
learn the
memorize it.
formulas.
Yeah. Aram, do the second one. Do you have any doubt while solving? For the first part, KB is equals to 2 over 3. 2 is constant and 3 is constant. So just neglect them. K is kinetic energy, for which dimension is ml squared T minus 2. And here T is temperature. So dimension formula would be capital K. So bring this particular part to the numerator. It will be ml squared T minus 2 and K minus 1. Similarly, for this particular value of S, rearrange it. So bring this particular mass to the other side and delta T to the other side. It will be Q divided by M times of delta T. Q is energy, which having same dimension as work, heat, and so on. M is mass, having dimension capital M, and delta T is temperature, having dimension capital K. Put them and rearrange. Rishan, send me your second answer. No, it won't be same. Here Q is energy, so it will be ml square T raised to the power minus 2. Here it is mass, capital M, and delta is temperature, so it will have capital K. This mass and this mass will cancel out, so we're left with L square T raised to the power minus 2 and K raised to the power minus 1. Is it clear to everyone? Riba?
Yes, sir.
Rehab?
Yes, sir.
Any doubt?
No, sir.
Okay. Next one is define some electrical term. For the electrical term, first try to define the dimension of charge. Have you learned any formula related to this particular charge? Abhinav?
Yes, sir.
Tell me any formula related to this particular charge.
Sir, I don't remember.
There was a chapter in your class 10 last year. Rate of flow of charge is called
QR.
current.
No.
Okay. So here I is current and T is time. So rearrange this to find this particular value of Q. So it would be Q is equals to current into time. Current is a fundamental quantity having dimension A
Ampere.
and time is capital T. So the dimension formula of charge is nothing but A into T. So now we have to calculate or to define three different terms. First is resistance. Second thing is capacitance. And third is inductance. These are just property of that particular substances. Like resistance, we have learned in our last class, the property of any substance to oppose the flow of charge through it is called resistance, denoted by R. Similarly, capacitance, for which you will learn in your next class on class 12, capacitance is the ability of a substance to store charge like a battery. But battery stores energy, electrical energy in the form of chemical. But this particular device stores electrical energy in the form of charge. And this is represented as capital C. Inductance, the property of coil, like resistance, has ability to oppose flow of charge through any particular substance. Inductance has ability to oppose variable current when passed through any coil. So this is the tendency of a coil to oppose variable current through it, and it is denoted by L. Now, the formula for these particular term I am defining you. H is equals to I square R into T, where H is heat energy, R is resistance, and T is time. We have dimension formula for current, dimension formula for time. Just rearrange them to find this particular dimension as R. Similarly, for potential energy, E is equals to half times of charge square over capacitance. Q is charge, for which we have dimension formula as AT. E is energy. Just rearrange them to find the dimension formula of this particular C. Similarly, for inductance, E is equals to half times Li square. E is energy, I is current, and L is nothing but inductance. Any doubt in these formula or
No,
any other
sir.
term? Okay, just rearrange them and try to find RLC, dimensional formula of them. Rishan, any doubt?
No, sir.
Okay. Gita,
Yes, sir.
As we have learned in our last class, how to calculate the dimension of different physical quantity. On the basis of that, we are just trying to calculate further more dimension related to some electrical term. So I have defined you three different terms. First is resistance, second is capacitance, and third is inductance. And we have formula related to those terms. Just try to rearrange them and try to obtain the dimension formula of individual R, C, and L. Okay? Good, Nida. Try to solve the next part. Good, Rupa. Try to solve the next part. Abhinav, solve the first part.
Yes, sir.
Send your first answer first. Okay. Ishan, dimension formula of current is ampere. So just write A in place of I. Otherwise, correct. And Abhinav, here we have Q squared. So the
Okay.
dimension of each term would be squared.
Yes, sir.
Rehab, send me your answer. So because we have to just rearrange these terms to find R. So by rearranging, R would be nothing but H divided by I square into T. Okay. So here H is heat, it means energy. And we have done in our last class, the dimension formula of energy, work, heat are same. I is current, so put A square, and T is time, so just put capital T.
Okay, sir.
Okay. Good, Nida. Abhinav, check your exponential of T.
Yes, sir, I saw.
Okay. Aram, check your exponential of T. They have just put for current as A. The dimension formula of current is in terms of ampere as capital A. Otherwise, your answer is correct. Riba, you haven't solved the first one.
I've sent you the answer, sir. The second one as well.
Okay, good. Both are correct. Good, Rishan. Good, Nida. Sabita, any doubt? Check your exponential of T. Sabita, check your exponential of T. Okay, no problem, Rishan. Ihab, send your second answer. Third. The first one is H is heat, so it will be ml squared T minus 2. I is current, so it would be A square and T. If you bring this particular T to the numerator, its exponential will become -1. So -2 and -1 becomes -3. So it will be ml squared T raised to the power -3, A raised to the power -2. For the dimension of current, use A. Otherwise, correct, Adam. Abhinav, here it is I square.
Yes, sir. I forgot about the power.
Good, Riba. Rehab, send me your answer. Sabita, is it clear to you? This one? Okay, good. Send me your third answer. Rehab, check your exponential of E. For the third answer. Good, Sabita. Solve third one. Here we have L. So it will be L is equals to 2 times of E divided by I square. 2 is constant. So it will be dimensionless. So just neglect this part. E is energy and I is current. So it will be ml squared T minus 2 divided by A square. So if you bring this particular part to the numerator, it will becomes ml squared T minus 2 and A minus 2. Okay.
Yes, sir.
So we have done these section. Now, any doubt to anyone of you? Okay. The next part is to define principle of homogeneity. Before defining the application, You must have learned about this particular word homo, like homogeneous mixture, homologous organ, homologous series, and so on. Homogeneous means similar or same type. So what it actually mean in this particular dimension term? Let me explain you. As we have started learning algebra in our mathematics part, it was like, suppose you have expression 2x minus 5x squared plus 3x plus x squared. And if I ask you to just simplify this particular expression, how would you simplify this particular term? First, this particular part has variable 2x and this particular part has variable 2x. So these two terms will be treated as like term. While adding or subtracting, like terms will be added or subtracted, but unlike term could not. Similarly, this particular term and this particular term has same variable as x squared. So these two terms can be treated as like term. So like term will be added or subtracted. So 2x and 3x will become 5x. Minus of 5x squared and plus of x squared will become minus of 4x squared. So what we have used in this particular expression to simplify, just the use of like terms and unlike term. Like term means the variable which contain similar exponential, like x and x, similarly x squared and x squared. In the same way, if we have to treat dimension, we define a particular term that is called principle of homogeneity. It tells you if two physical quantity will be added, subtracted, or equated, it would be always possible if the two quantity would have same dimension. It means two different quantity having different dimensions can never be added, subtracted, or equated. Likewise, we have for like term. Only like terms will be added or subtracted, unlike term would never be added, subtracted. Okay. So this particular principle of homogeneity state two physical quantity can be added, subtracted, or equated only if they have same dimension or dimensional formula. Suppose if there is written a plus b, a minus b, or a is equals to b, these all three expressions would be possible if a and b would have same dimension. If a and b same dimension. Is it clear to everyone?
Yes,
Yes,
sir.
Sabita, any doubt? Okay. So for this particular term, I'm giving you one example. I'm trying to solve so that it will become more clear. Suppose if there is expression b minus a over b square times b minus b is equals to c. Here in this particular expression, b is representing pressure, b is volume. We have to find dimension formula or dimension of A, B, and C. So how to approach this particular problem? Just start from each bracket. In the first bracket, we have two terms. First one is P and the next one is A over B squared. And there is a negative sign in between them. So by the use of this particular concept, two physical quantity can be subtracted only if they would have same dimension according to the principle of homogeneity. Is it clear?
Yes, sir.
So we can say this particular term and this particular term would have same dimension. So just equate them. In this particular equation, we have dimension formula for pressure and we have dimension formula for volume. So on rearranging them, we would be able to calculate dimension formula for A. Okay, Rishan? Is it clear? They have any doubt? Okay. For this particular expression, just say, see in this particular bracket, we have two parts. First is P and the next part is A over V square. And there is a negative sign in between them. So as we have stated in this particular expression, if two quantities is related to one another by addition, subtraction, or is equals to, this particular relation would be possible only if they would have same dimension. So as these two terms are related with some negative sign, so it means this whole term and this whole term would have same dimension. Okay, Rishan? Now, for P, we have dimension as ml to the power minus 1, t raised to the power minus 2 is equals to A divided by volume. For volume, we have dimension formula as LQ to the power 2, so it will becomes L to the power 6. On bringing this particular to the left hand side, it will becomes M L to the power 5 and T raised to the power minus 2 as dimension formula for A. Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay. Now, for this particular second part, Samita, tell me the relation between V and B. Iram, what would be the relation between V and B in this particular expression? For the second bracket,
They will have same dimension.
good. As they are related with some negative sign, so it means they would have same dimension. So we can write B is equals to V. Dimension formula of this particular volume is nothing but LQ. Is it clear to everyone?
Yes, sir.
Yes, sir.
Sabita, any doubt?
No, sir.
Okay, just write it down. I'm explaining you how to solve third part, that is C.
Sir,
Yes.
sir, for C, can we equate it with like V minus B is equal to C? Or we have
No.
to take the whole expression?
For as C is equals to the whole expression in the two different bracket. There is some other concept related to that. I'm explaining you.
Okay, sir.
Nida, any doubt?
No, sir.
Have you all written?
Yes, sir.
Savita?
Yes, sir.
Written?
Yeah, I finished.
Rishan? Okay. So how to define this particular C? For this, I'm giving one more example. Suppose if you have to add 2x plus 3x, and if you have to subtract 4x minus 4x. So what would be your answer for this particular first expression?
5x.
So it will be just 5x. Similarly, for this particular part, yes.
0.
Let's see, while adding, the variable of this particular expression remains same. Only the coefficient gets added or subtracted on the basis of that particular binary operation. So for this, we can write 4 minus 4 as 0 times x, and 0 multiplied with any particular term would give you 0. So we would say 4 minus 4x is nothing but 0. Similarly, for the dimension analysis, suppose if we have L plus L, so it will give you nothing but 2 times of L. This particular 2 is a numerical part for which there is no dimension. So we can neglect this particular part and we're left with nothing but L. Similarly, if you have to subtract L minus L, it will be nothing but 0 times of L, and 0 is any numerical value which is constant. So we can write, or we can simply neglect this particular 0. So we're left with nothing but L only. So from this, we can conclude in the case of dimension only, L plus L will gives you L only. Similarly, L minus L will gives you L only. Is it clear? This mathematics is based on dimension. Okay. Abhinav, any doubt?
No, sir.
Likewise, this particular expression, as we have done for the last part, P minus A over V square. The next part is V minus B is equals to C. Just see in this particular expression, this is your first part, P, and this is your A over V square, the second part. So this particular part and this particular part would have the same quantity or would represent the same quantity as pressure. So we can write this as P. Similarly, we can write this particular term as P as well. If there is negative sign in between them, so P minus P gives you nothing but 0 or anything else. Aram?
0.
It's P.
Good. As we have discussed this particular term, L plus L with nothing but L itself. Similarly, L minus L would give you nothing but L itself. 2 and 0 are numerical part which are dimensionless constant. So we just neglect them in the case of dimension. Okay, Abhinav?
Yes, sir.
Now, for the next part, this is your volume. So this must be your volume. So this is your V. So this is again V. So V minus V would give you nothing but
V.
Good. And what is the sign in between these two brackets?
Multiplication.
And it will equate to nothing but,
C.
now you would be able to calculate the dimension of C. Okay, just put the dimension of P as pressure, V as volume, and try to obtain the value of C. Try to solve, everyone. As we have discussed in our last class, all the numerical value are treated as dimensionless constant. Real number, pi, exponential function. Okay, Rishan? Good, Abhinav. Adam, we have just volume here. In the last part, there was LV square. So we have dimension as L to the power 6. Okay. We have just volume. So for volume, dimension formula is L cube only. Good, Riba?
Okay.
Rishan, check your exponential for V. For L, I think it would be a typing mistake. Rihab, check your dimension of L. This is just volume. So it will be just L cube. And P is nothing but pressure. There is no exponential other than 1 on it. Nida, send your answer. P is pressure having dimension ml to the power -1 and t raised to the power -2. We have to just multiply them to obtain C. Here, these two terms having same base, so on multiplication, their power will be added together. So it will be m L square and t -2. Is it clear to everyone?
Yes, sir.
Nida,
Yes, sir.
okay then. Let's stop here. I will continue in the next class, the dimension application, how to convert from one form to another, and how to derive relationship between any two physical quantity, and rest of the all part.
Hello.
Okay. Okay, Abhinav,
Sir, am I late? I think I'm in time, 7 o'clock.
just 1 minute. I'm starting your class.
Yes, sir. Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Okay.